the Geohash map for Kormangla, Bengaluru looks like this, okay? And let's say this is the entire Kormangla area, Uber or Rapido or Ola. How they are able to find the nearest driver for you in just a mere of seconds, right? That means because you are located in subquadrant C, it will try to fetch drivers in this location. Now it will find that it is not able to, right? Welcome back to the channel. So have you ever thought of, like, when you use some application like Uber or Rapido or Ola, how they are able to find the nearest driver for you in just a mere of seconds, right? So there are two important concepts of system designing. So basically geohashing and quadrant trees. So that's what we are going to discuss about today with examples, and we'll see how these two techniques enables these ride hailing platforms to leverage this technology and find the nearest driver for you in the quickest way possible. Okay, so first let's just start with the concept number one of geohashing. Okay, so what does geohashing means? There are two terms involved in it, right? Geo, then hash. So basically, what does it mean? Geo means the globe. What we do in geohashing, we divide the entire globe into some blocks of hashes. Okay, some hash values. So if you see this image here, which I've taken by the way from Geeks for Kicks. So in geohashing, what do? We divide the region, okay, into, let's say, multiple blocks. Okay, let's say here we first divided and if you see, there is a India map here, okay, in the background. So what we do, we divide it, let's say, into 4 quadrants. Then each division we can further subdivide it, okay. And if you see the prefixes that are there, the prefix of parent division is inherited to the child divisions, and then we append 0, 1, 2, 3 like this, right? Then again, if you want to, let's say, further subdivide 1, 3 into 4 more blocks, we can do this way. So this is how we convert the entire geographical map into blocks like this, and each block is given a hash value, right? It's a hash value. Don't worry, we will see an example in the end of this video, like how to convert a given latitude and longitude into a hash value like this. So I'll explain the logic. We will be using a concept called binary encoding there. I'll explain you there. But for now, let's just understand in the high level view. So if you can see here, we have just shown 3 divisions, okay? But are 3 divisions enough? 3 subdivisions like this? No, not really, right? If you see in block number 230, Kerala lies. Kerala somewhere falls in this 230 block number. So it doesn't, you cannot have just one block like this, right? If someone from Kerala is looking for a ride in, let's say, Rapido or Ola, you just cannot go and search the entire Kerala state, right? So we have to further subdivide it. So what we can do, we can further subdivide 230 into 230, 231, 232, 233 like this. Then again, we can further subdivide each of those subdivisions. So like this, how much you want to subdivide, that depends on your app and services that you are designing. Let's say you can define some rule like until each block is covering at least 3 or 4 kilometers of radius, okay, or let's say 20 or 30 degrees of latitude movement. You can define thresholds and rules like this for your application. Until it covers that threshold or that limit, you will keep on subdividing it. Now once you have done that, this entire geohashing is stored in a database. So it became like a static hash data for the entire geographical map of our globe. So once this is done, then comes the next crucial part. Okay, now let me just extract a portion of this geohash. Let's say I take this, okay, and I'll just import it here, okay. Here you can see there are 4-5 states that are coming in these 4 blocks, but let's just assume that this is what a map of let's say Kormangla looks like, right? Kormangla, Bengaluru looks like, okay. Just assume for the time being. We could have subdivided it into further strings, but that string will become lengthier, so I don't want to do that. Yeah, before jumping to this, let me just discuss one more point, okay. So if you see the prefix that we are generating, the numbers or the hash values that we are generating for the children blocks, if you see, the neighboring blocks will have similar prefix. If you see the block number 133 here, right, 133 has 4 neighboring blocks here which share the similar prefix of 13, which have been inherited from its parent. So that's what the beauty of geohashing is. So longer the shared prefix between two geohashes, the spatially closer they are together, right? That means if you see 132 and 133 are spatially closer. I mean, in the space they are closer because they share a common prefix. But 133 and 303 are not spatially closer, right? Because they do not share a common prefix at all. So that's how this geohashing is important. Now let's jump to this example, okay? Now let's say the geohash map for Kormangala, Bangalore looks like this, okay? And let's say this is the entire Kormangala area in Bangalore, which have been divided into 4 quadrants like this, okay? Now let's say you are a rider, okay? Let me just see if I have some icon for this. Okay, let's say you are a rider, all right, and you are searching for a cab or a taxi or a bike in Rapido app, okay? Now you will have your own latitude and longitude, okay, where you are staying currently. And let's say when we convert this latitude and longitude into geohash, so we'll basically pass this into a geohashing algorithm. As I told, I'll explain this in detail with an example in the end of the video, okay? And let's say you passed in the latitude and longitude for this and it generated a hash value or geohash value of 213 for you, okay? That means you as a user are actually falling in this quadrant, okay? So you are let's say here, all right? Now what will happen? Now once your geohash value is determined by the application using its own geohashing algorithm. So now what it will do? Now this is where the second concept which we are discussing in the beginning of the video, quadrant-tree or QuadTree comes into picture. Okay. Now what QuadTree will do? It will first identify that you as a user are located in the geohash value of 213. So in this block you are located, right, in this quadrant. So what it will do? It will first try to fetch the nearest available riders. Okay. Don't have taxi or something like that. Let me just import it from somewhere. Let's say we have multiple taxis available like this. Okay. Let's say we have taxis available like this in this quadrant. All right. Now what this quadrant tree or QuadTree algorithm will try to do? Now what is a quadrant tree algorithm? It's basically divides a given two-dimensional space. So this is a two-dimensional space, right? So QuadTree, what it will do? It will basically divide that given two-dimensional space into 4 equally spaced quadrant. So it will further subdivide it. Okay. If we further subdivide it, now before subdividing, first what it will try to find out whether we have some taxi or some target points. So here target points are taxi drivers, right, or the taxis. So whether the QuadTree in the current quadrant, if it has some target elements or not, or taxis or not. If it has, what it will do? It will then try to narrow down the search space. Okay. See, one thing it could have done, once it determined that yes, we have some taxi in this quadrant, okay, in this main quadrant, first quadrant, or in this 2D space, what it could have done, it could have simply, calculated a distance between your location and the taxi's location for each individual taxis, then whichever is closest, right? So whichever is the closest, let's say this is the closest, it would simply assign you that taxi for you to ride, right? But ideally it doesn't do that, okay? Because we can always, if we have options to optimize the things, why not to do that, right? So what it will do? it will further subdivide it into 4 equally spaced quadrant. Okay, that's why it is a quad tree. That means four subtrees or 4 branches it is creating, 4 quadrants it is creating for a given quadrant, right? So what it will do, let's say it will divide it. Let me just change the color a bit to black. So so it divided this 2-dimensional space into 4 equally spaced quadrant, right? Now out of this, now what it will try to do, it will then again figure out in which quadrant. Let's say the 4 subquadrant that has been generated are A, B, C and D. So let's say this is A, B, C and D. Okay, in clockwise manner I am typing A, B, C and D. Now if you see, the user is located in quadrant C, right? So the first priority, the quadrant tree algorithm will give it to subquadrant C. What it will do, it will first try to search for drivers or taxis in this quadrant. That means because you are located in subquadrant C, it will try to fetch drivers in this location. Now it will find that it is not able to, right? Because here you see there are no drivers available. Then what it will do, because C was discarded, because it could not find C driver in quadrant C, we are left with A, B and D. Then what it will do, it will look for the nearest quadrant. So there are 2 nearest quadrants, B and D, right? Because we moved in clockwise, A, B, C and D. So B and D are available. So it will then try to search in these 2 quadrants. Okay. Now you see that in quadrant B we have a driver, and quadrant D also we have a driver. So we have 2 options left right now, right? The algorithm has 2 options to choose now. Now what it will do for each taxi, okay? Now for each taxi, it has its own latitude and longitude, right? Because taxi are present, right, in a physical location. It will have latitude and longitude. Now for each taxi, it will calculate the geohash. Okay. It will calculate the geohash for each of them. Let's say geohash value for this is, the first taxi is, let's say 213001 or 112, something like this. And for this taxi it is, let's say 21300304. Okay, I mean now using these geohash values, what it will do, it will then try to calculate the distance, the closest available taxi for your location. It will then try to calculate the distance for these 2 taxi and then assign you a taxi driver for you. Okay, let's say it did not find any taxi at all. Okay, or let's discuss the other way around. Let's say it again found, let's say, multiple drivers here, right? Okay, in this space. So what it could do, it could recursively again divide it into 4 more subquadrants, okay, to narrow down the search more, right? It could have done that, and it does that actually. How does QuadTrees work actually? They recursively divide a given physical 2D space until they reach at a point where the target points are available. So now you might think, I mean, how deep it will go, how much recursively it will go on dividing the quadrants. It cannot go to an infinite level, right? There again, it becomes the requirement of your application. So what you can define, you can define threshold and rules for your application, that if a quadrant has more than 5 drivers or 10 drivers, right? Let's say 10 is the threshold. So if a quadrant has more than 10 drivers, subdivide it into four parts. Okay, so you can define thresholds like this so that you can narrow down the search space, okay, and then find the nearest driver as fast as possible. So that's how the quadrant tree algorithm works, okay, along with geohashing, to fetch you the nearest available driver for you, and then it assigns you your desired taxi or cab within just matter of seconds and minutes. Okay, so this is the entire algorithm and technique of how this geohash and quadrant tree or quad tree collectively work together to give you the fastest ride possible. So however, in practice, hash values that are generated are not done using just like this numbers. They will use a combination of numbers and alphabet numeric characters using which they will calculate the geohashes. Okay, so I hope you understood about the geohash and QuadTree and how do they work together. Now just let's look at the example which I told you earlier. Like we'll see a illustration of how do we convert a given latitude and longitude. Here we saw, right, we converted a latitude longitude into a geohash value using our geohashing algorithm. Let's see example of how this geohash algorithm works actually. Okay, so how geohashing is done? It is done in binary encoding. Now what does binary encoding mean? Binary encoding is kind of a binary search kind of thing. Okay, so just like you calculate, LCM and GCM for numbers, right? It's similar to that only, but using binary search. So what it will do, let's say we have a latitude value of 48.8566 and we want to encode it, okay, using 5-bit binary representation, because let's say our application requirement is till 5-bit, we'll subdivide it. Now what we do, let's say the latitude is 48.85, right? Now what we'll do, we'll normalize the latitude in range of -90 to 90 degree and normalize the longitude in range of -180 and 180 degree. Okay, now let's just see for the latitude. Okay, now we have a range of -90 degree to 90 degree with us. Okay, and then we calculate the midpoint. See, we are using the binary search, nothing else. So we calculated the midpoint is 0. Okay, now 48.856 is greater than 0. That means the number 48.85 lies in the upper half, right? I mean, 0 to -90 is the first half, 0 to +90 is the second half. So in the upper half, 48.856 lies. So because it lies in upper half, we'll have 1 we'll add 1 to our binary representation of the geohash. Okay, now similarly the new range is 0 to 90 for us, right? Then again we'll divide. We'll again see that 48 is greater than 45. We'll add 1. So similarly we do all these processes. You see, new range became 48 to 90. Then again we divided. The midpoint was 67.5. 48 is less than 67. So that's why it is in lower half. That's why we added 0 into our binary representation of the geohash. Similarly, we go on dividing like this, and we generated 5 bits. Okay, if you see, the more deeper you go, I mean, let's say I want to divide it more. I mean, the more number of bits you want to have, the more precision we will have in the generated geohash. Okay, further you divide it, the more closer you'll get to the original, I mean the actual latitude and longitude of the user. Okay, but here for example you have taken 5 bits. Now you combine all these 5 bits, so it generated a binary number of 11000, combining all the bits from this binary encoding method, and where 1 represents the choice in the upper half region and 0 represents the choice in the lower half region, right? So latitude is this much, and let's say longitude is, using similar technique we calculated longitude. Let's say the longitude turns out to be 10001. Okay, now what we do, we'll interleave the latitude and longitude. That means we'll pick one character from longitude, one character from latitude, add it, then one from latitude, one from longitude, one from latitude, one from longitude. Like this you pick the bits one by one from longitude, then one from latitude, then one from latitude, 0 from longitude, 0 from latitude, 0 from longitude, so on and so forth. You generate the interleaved binary. Okay, we're basically interleaving those two things. Now once we get the interleaved binary form, what we can do, here we have taken base 10. Okay, you can use base 32 also. Base 32 means we'll have, let's say, 10 numbers. Okay, 0 to 9 are 10 numbers or 10 digits, and 22 alphabets. Okay, or base 36 you can use. So based on the application requirement, you can you can define your own base. Okay, for simplicity I have taken base 10 here, and converting this to base 10 it becomes 901. Okay, that means the user with this latitude and longitude, whatever, some longitude, let's say 2.5 degree, has the geohash value of 901. Okay, we can tell that the user is a part of this, let's say 901 block. Okay, just like we have 330, there will be a 901 block also. So that's how you calculate the geohash, provided you are given with the latitude and longitude value, okay, of that user. So that was about today's video. I mean, I hope you understood the two powerful concepts of geohashing and QuadTree or QuadTree, and how they are, combinedly working together to generate the nearest available drivers for you in your ride app, right? So if you got to learn something, so just hit the thumbs up button of this video. So geohashing is actually, one of the important algorithms which you should learn along with QuadTree before you are preparing for any system design interviews. So this algorithm is quite important for you to learn. Okay. So if you like this video, subscribe to my channel. We are targeting to reach 2200 subscribers by the end of this month. I'm going to create such useful system design applications which are done in real life, actually, in real life applications, and I'll explain you the concept in the easiest way possible. I'll try my best. So yeah, thanks for watching this video, and I'll see you in the next one. Thank you.